Okay, but the thing is, like,
all right, worksheet I, here it comes. We have homework.
I can't even laugh at that just because like actually it's so hard. And it sucks. Oh.
Watch this, I'll talk to you more.
In dance, my very first time. So bad.
Oh no! I was taking my math test and I was sitting
I'm
next.
opening it.
I was in white jeans. Don't worry, I think I did it.
That's
Oh,
so
here it is.
unfortunate.
Here you
I'm
go.
so sorry.
Here, I have it too.
You should put your name on it. You gotta be like Hannah. A good kid like Hannah.
Yeah, come on, Olivia.
Please, oh no! Oh, absolutely tragic.
Tragic. Middle mark.
I tried that. Okay.
No.
I did it all.
Yay.
Does anyone?
You whited it out.
I did what?
Right? Like, what? They felt. I can't drive that car anymore.
Don't judge me.
Don't
judge me. Yeah. I went up to 40 because I did 7 already. 7?
Dude, why was Cody like crying?
Riley gets mad at me.
Saturday?
Why would she get mad at me?
We were like making fun of him, like.
Wait, why don't I get caught?
He's so pissed.
And he just goes.
Did you do it?
She did.
He gets so mad all the time for no
I do it
reason.
hard too. I just
And he's still so mad
Sometimes
at
I
Valerie,
work hard.
but he wants to
But I
call
won't
her
work
like
hard.
every night to apologize.
You
This
talked to him?
weekend was just really.
I stopped responding.
Dude, that's so
You
weird.
just can't
He
respond to him.
keeps talking to Sammy.
I know, he keeps. He'll
And Sammy
he'll
just
just
keeps
vent.
responding.
He'll just vent for if you say if you like listen to his problems once he will just depend on you.
Yeah, if you ask him if he's okay, he just goes off.
That's when you say, go talk to a pastor or something.
He hates Valerie, but he is in
Loves
love
her.
with her.
That's how I feel.
Same.
Dude, did you see all of it?
Yeah, dude, I was there, man. He was just asleep under the ottoman.
All right.
That was the funniest.
Well, I hope you all had a nice weekend. I think I did.
What'd you do this weekend, Mr. Stewart?
You know, it was a restful time.
You see the McGregor fight?
No, I didn't.
Crazy. Crazy.
Shut up. No. Hold it. No.
I actually didn't put up. I did put the gloves on this weekend. I did a little 3-round boxing match with a guy at the gym. That was fun.
Did you win?
I would say I out-tagged him. Definitely. I mean, we're wearing full face guards, so we're not marked. Huh? No. I could. The problem is if I wasn't able to tag him hard enough with a fist, but if I would have went to an elbow,
You're a big elbow guy.
that's my go-to. I mean, but that's how I was trained. But just regular boxing, it's like there's rules where it's like I can only hit with here and here.
Wait, can you show us some boxing moves?
Boom.
Oh, I get to learn Taekwondo and aerobics
Keep your
tomorrow.
fists up. Keep your fists up like this, and you move it, and you punch along your face like this. This one.
Tour cast.
Yes. All right. Enough about me. Let's talk about you. Questions on 5i. There's not time.
Have you ever gone to fight?
No. Unfortunately, no.
That's a lie.
I know.
That's a lot.
Yeah.
46?
46. 46. There we go. All right. So I get 8 root 3 minus 1/2. All right. So we wanted to look at this, see if we could simplify it down. 8 root 3 is already simplified down as much as possible. So 8 root 3 will just come down like this. And then I do have 1/2. And then let's break 48 down to 16 times 3. The reason I'm choosing 16 and 3 is 16 is the thank you, or it's the largest perfect square, right? All right, what's the square root of 16? 4. So square root of 16 is 4. What's half of 4? 2. 2.
Negative 2.
So I get that. These are now like terms, so I can reduce it, so I get 6 root 3. Yes,
I did 7 and 4 instead of 16 and 3. So I got 4 root 7.
So if you did, what'd you do? Did you do 8 and 6, 4 and 12?
12 and 4.
So if you did 12 and 4, it won't reduce all the way. Some of you are talking too much. So 12 and 4. So you would have gotten 2 root 12. And the problem with 2 root 12 is that you still have a perfect square in there.
But if you do 8 and 6,
8 and 6.
doesn't work too.
Right? And I'll show you how, if you wanted to break these down, if you wanted to break 48 down, 48, think of it this way. 2 times 24, 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3. So 2 times 2 is 4, 8, 16, 3. So this is a perfect square, this is a perfect square. 2 of them come out, so there's 4 outside. So you could think of it that way if you wanted to.
Yeah.
And there's nothing wrong with thinking of it that way. Some people are like, no, you got to think my way. It's the only way. I think, no, it is. All right, what other questions might you have off of I? 19. I am with you on 19. All right. So x plus 25 quantity squared is a perfect square because the whole thing's squared. So if I take the square root of, if I take this, that all goes away because it's squared, so I'm just left with x plus 25.
I don't think so. That's not 19. 19
Wrong.
is 5 over.
Oh.
Wrong.
So that's number 18 in case anyone had a question on that. Sorry, 19. Sorry. So 5 over 81 x squared. That one?
Mm-hmm.
And this is all under there. All right, so perfect squares, that should stick out. This is a perfect square. It would be nice to change on this as well. So I have root 5 over 9, and then I have x squared. Oh, not x squared. Bless you. The square root of x squared is just x. Bless you. Okay, why is this thing still magically off? Who's been messing with the projector?
Everyone.
Don't count me in.
Which one?
Is that okay? On this one, some of you might want to know, could I have this? And the answer is yes. Just be careful not to have that go all the way. Okay. Shh. Too much talking. Too much talking. What else? 3-1? All right. 31. Is that the root, negative root 14?
Yes, and then 3.
All right. How I might approach this problem is let's break everything down inside the radical and keep anything outside the radical free and clear right now. So right now, I'm going to break 14 down to 2 and 7. Those are the prime components. And then 35 breaks down to 5 and 7. Is that okay?
Yeah.
So that times that's 49. So the square root of 49 is 7. That'll join this negative 3 outside. So I get negative 21 over root 10. Done. What else? Good shot.
I'm just wondering, if you multiply the inside and the outside, and then you do it, would you get the same thing?
Yes, if you multiply 14 times 35, you would definitely get think it was a 700.
44.
49. 490.
Okay, sounds good.
44.
44. $44. 7 root 45 minus root 80. Okay, this one, because you're just subtracting it, you have to do each part alone. So 45 breaks down to 9 times 5. And then this breaks down to 16 times 5, I believe. So square root of 9 is 3. It multiplies with this, so I get 21 root 5 minus 4 root 5. And then that. Yeah.
So you do 40.
Yeah. Okay, so we're just subtracting them. You can't subtract them as they sit. Root 7 won't break down any further. So this will stay as this for right now. Minus, I can break 28 down to 4 times 7. Don't do 2 and 14 because 4 is the largest perfect square. So 3 root 7 minus square root of 4 is 2. Bring it outside so that it becomes this. And then go ahead and subtract so you get negative 1 root 7, which you could have as negative root 7. You could keep the 1 there if you wanted to, though. Anything else? Yeah.
What about 26?
2/6. All right, so the 4x minus 3 is being squared. So let's just go across this. That's going to give me 5. And then this, the square and the square root and the square, or the root and the square, is just going to make it come down to this. So you could leave it like this. I guess you could distribute over which answer is more correct.
Wait, why doesn't before simplify?
Oh, great question. Okay, so the square root and this are going to knock each other out, and then that's going to leave that all alone. Because technically I have, let's look at it this way. Break it down to prime components. Because I have a pair of these, that brings the 5 out. Because I have the pair of these, that brings this out. Cool.
Okay.
Anything else? Go once. Once, twice. Will you make sure your name is on that and anything else you might be handing in? I did. Your quiz grades are in. So they're looking good. I will eventually convert that to a percentage in there once it's in. Once everyone's done. So I heard we got fall break coming up, huh?
Yeah. Isn't it? When is it? Next week?
bros.
Yeah, baby.
So this is our last week.
Last week.
And
Then when's Halloween? The week after?
It's next or 2 Wednesdays from this.
Oh man.
Please tell me you're off school the next day.
I love Wednesdays.
We do, but I tell you what, I got a Halloween story that I'll tell on Halloween that if you thought the Eddie story was good, you wait till the Halloween story.
I don't get why we have school the next day because no one's going to school until trick-or-treating all night.
Thank you.
This is 5H.
Perfect. Works for me. I'll figure it all out. Thanks so much. All right.
Then you guys want to play some squad?
Yeah, you guys are coming up on a great time of year. Man, oh man. Put on top of you.
Picture of days, bro. Do you guys know that, man? No. I bought that thing, bro. I know that. Like crazy killing me. No.
Which one do you think is better? This one?
That's hard to do.
No, like Final Destination. You're chatting with my man.
It's not me, it's Gabby. It's Gabby and Julia.
Misunderstanding what I'm trying to say.
All right.
Like
I answer questions, I'm like anyone else.
Good. Thank you for doing that. Y'all ready for this?
Is this the same thing as that?
We can't say.
I hope not. I don't think it is.
I feel like we kind of did it.
It's the F word. Deal with it.
The reason why I have a C in this class.
I will start eliminating fractions. We'll everything will come out a nice whole number now. All right, rationalizing denominators, including conjugates. Okay, it's not conjugate. We're not in Latin or French or Spanish. We're not conjugating verbs.
Good.
Good.
Spanish sucks.
C. Extend the understanding. Okay, we're good. All right, let's move on. Woo! Okay, write in simplest radical form. So a lot of students might see this problem real quick and say, oh, sweet, we're done. This is a 2-point problem. You got 1 point so far. Why is that?
4.
Yeah, 12 is going to break down, right? So 4 and 3. So square root of 4 is 2. So I get 2 root 3 over 5. Got it right?
Yep.
And then problem number 2. Well, I know that 25 times 3 is going to work on top, but unfortunately, we're not really there. So let's take, let's multiply both the top and the bottom by root 6 and root 6. Root 6 over root 6 is the same thing as 1, so I'm not changing the fraction at all. And so maybe I'll start breaking down 75. I know 75 is 3 times 25. And then 6 is this. And then that becomes root 6 times root 6 is root 36, which is
No, what?
root 6 times root 6 is root 36, which is 6.
Wouldn't root 6 times root 6 should be 6?
Yeah.
Well, it becomes root 36.
Yeah. I'm so dumb. It's fine.
We don't hold it against you, though. All right, so now I'm looking for pairs. If I look for pairs, those are perfect squares. So if I pull out the 3 times 3, which is square root of 9, I get a 3 outside. 5 times 5 is 25, so square root of that's that. So I just have a root 2. So I have 15 root 2 all over 6. And then a lot of you would be like, sweet, I'm all done. And then you get take a look at your quiz and you're like, wait a minute, I missed 1 point. Why is that? Well, what number goes both into 6 and 15? 3. So I got 5 root 2 over 2. And then a lot of people are like, oh, sweet, the 2's cancel out. No, you can't cancel out. You can't cancel something inside to something outside. Yeah.
So when it's not like a perfect square on the bottom, we multiply the top by the bottom.
Yeah, you try and get to the bottom to be a perfect square. So on this one, a lot of students might start this out and say, oh, sweet, we're done. Never. Excuse me. Let's multiply top and bottom by root 7, root 7. So I get 3 times root 7, which is 3 root 7. Root 7, oops, that should be a 7, I'm sorry. And then root 7 times root 7 is root 49. Root 49 is?
7.
3 and 7 do not reduce, so we're done. So 3 root 7 over 7.
Next. Cool. Cash.
These are nice exact answers. Number 4, you might see this as
1/2.
1/2. Right?
Yeah.
Does everyone agree with how I did that? If I just reduce this, and then square root of 1 is 1, then I multiply both top and bottom by root 2. So 1 times root 2 is root 2. Root 2 times root 2 is root 4. Root 4 is 2.
Cool.
That's actually an answer you'll see a lot of when we get into the trig part, because the sine and the cosine of 45 degrees is root 2 over 2.
Okay.
When we start getting into the trig unit, there's only like 6 answers that are any of the answers in trig.
I'm good.
1/2 root 2 over 2. root 3 over 2, root 3. So some of you have a chance. I can guess it. All right. So remember that you must multiply. Remember that you must multiply by 1. So that's when I multiply by 1. That means you're just multiplying the top and the bottom by the exact same radical. Is everyone okay if I just double distribute and do this real quick? Anyone need to see that worked out?
No.
Okay, and then this one, you double distribute, you get this. What is this one called?
Difference of 2 squares.
Difference of 2 squares. So if I have x minus 4 and x plus 4, those are actually conjugate binomials of each other. You're one sign different. And then number 7, root 6 times root 6 is root 36, so it just comes out to 6.
2b.
And then this next one is just 2b, because if you multiply 2b and 2b together, you get 4b squared. The square root of 4b squared, or root 4b squared, is 2b.
Yep.
Anyone stuck on any of those?
Nope.
Cool, moving on. All right, so think about this. How can we rationalize this denominator? I don't want a radical downstairs. That's like a big no-no in math.
Multiply by the top thing and the bottom.
Yes.
That's it.
Right. So multiply both the top and bottom by 3 and 2 root 5.
No, it's no.
Root
It's
5
plus,
over
so it's
7.
not the same. Root 5. You just multiply.
Multiply by what?
Root 5 to the top and bottom.
Okay, if I multiply both top and bottom by root 5, that would give me 3 root 5,
Over 7.
2 root 5, plus 5.
Okay, what?
Right? You agree with that?
Because if you multiply. Huh?
Okay, so
Wait,
that cancels out. You can't do that. So what I'm going to do on this problem is this. Ready? Eyes up here. Cell phones away. They should be in the side thing. Mine's being charged in my office. All right. Ready?
Yes.
So let's look back here. Look at x minus 4x plus 4. What goes away on that?
X minus plus 4.
Yeah, the middle terms, right?
Yeah.
Yes.
So if I multiply this,
I don't get this.
if I multiply my denominator by this,
So you multiply.
and I multiply the top by the same thing,
Oh,
so I'm
yeah,
multiplying
that's-
top and bottom by the exact same thing. So I'm making my fraction no longer a reduced fraction is what I'm doing. Okay, so on top, multiply here and here, so that's going to give me 6 minus 3 root 5. Is that okay?
Yep. Over 1.
And then if I multiply the bottom,
No.
I'm going to get 4 minus 5. And let me stop there for a second. Is that legitimate how I did it? If I double distribute or I FOILed, I get 2 times 2, which is 4. Agree?
Yes.
Then the outside terms, 2 times negative root 5 is 2 negative root 5. Or negative 2 root 5. The inside becomes 2 root 5, so they cancel out. And then the end, I get root 5 times root 5, which is root 25, which comes out to just 5. So it becomes minus 1, or minus 5. And then I can reduce this, so I'm going to get 6 minus 3 root 5 over negative 1. And I guess if I truly want to simplify this a little bit better, I get this for an answer. Okay, why did everything change on that last one?
Because you multiply the top by the denominator.
Yeah, I multiplied everything by that negative. Okay, it's gone. Got rid of it. Now, let me kind of just go into where this math is used. Okay, so I know you all have cool phones.
No.
But does any of your parents do the freaky thing where they are Find My Friends because they always want to see where your phone is?
That is literally always.
Okay, you know what I'm talking about, right?
No, because my parents trust me.
So I want to be that parent, and I've only been that parent once to my daughters, and it was when 8th grade when they went to Spain for 2 weeks, because I just wanted to see. They're supposed to be in this area, and I'd pull it up, and I'd say, oh, look, they're in this hotel. Sweet. So it made me as a dad feel better about my kids being, 5,000 miles away. But how close how close is that Find My Friends on your phone in actuality?
No, it's
Do you think it's like within 50 feet?
No, it's like spot on.
It's
Pretty spot on?
no, it's pretty.
Yes. It's,
I mean, could it be within a couple inches, maybe a couple feet?
No,
Would that be
it's actually exactly where you are.
The
exactly?
exact coordinates.
So it's exactly. So they used to be within. I think it used to be within 9 feet, a radius of 9 feet. Which you think, wow, you have the whole world and you're getting within 9 feet of where that person's at, which is pretty cool. What the cell phone companies have done now, they keep buying the technology that the federal government uses in our satellites. Okay, because it's like the government wants to take care of stuff, saying, sure, you want to use our technology, it's going to cost you this much, and then Google's like, yeah, baby, and you have like this exact stuff. Those kind of exact answers are what they're using to get the calibrations correctly. Okay, your computer cannot do math, but it can do iterations to get to a sequence of numbers, and that becomes the summation of an event, which means I've added a whole bunch of small numbers together to get to that. But that's an exact answer. So the closer and closer, I mean, what will we really come to on the cell phones? I'd say our next generation cell phone, with probably when you all are in college, maybe just graduating from college, it's going to be weird because it'll be Find My Friend, and it would give you a live drone feed where it's looking, oh, look, there's that moron. Wait, I did. Okay? So, and people are like, no, I wouldn't get to that.
no, they're gonna have chips in their.
Well, the scary thing is we could get to that. Right now we're putting microchips in dogs so we can track our dogs. Just imagine, it's a matter of time before, hey, Mom and Dad, we can put this little microchip behind your child's ear in case they ever get kidnapped and we can find them. It builds on the emotion of people, right?
It sounds like Black Mirror.
Sounds like the greatest thing in the world, right? But it's scary. But if you're a parent, if you're a brand new parent, you got this, little, 4 to 8 pound thing that poops all the time. You want to make sure they're always safe, so making that decision, saying, hey, put a little microchip in my kid, we can always find them, seems like such a good idea until, what's the next level of it?
Robots.
And then it's
where are you at? I mean, you never have a privacy.
That's literally Black Mirror. It's literally.
So then, I mean, think about this. They already have this on your cell phone. I would say when you start walking into stores, they have Google stores that are already doing this. Google store already kind of knows what you want as you walk into it. Okay, these are actual grocery stores.
You'll be thinking about something and then the ad pops up and you're just like, what? I hate that.
Yeah, it's a little kooky. But that's what technology's doing to us. Let's go. All right.
No, I can't. I don't have an app because,
Whoa.
Okay, I'll remove that.
She does whatever. She's the worst. I've only heard.
All right. So conjugates are binomial expressions that have exactly the same terms, but one is added and one is subtracted. That's the only thing what a conjugate is. Boy, didn't you wish conjugates were that easy when you're taking French? Conjugation of verbs. I still remember conjugating verbs in Latin when I took Latin in high school.
Why would you take Latin?
It's a dead language, man.
Yeah, it's good for SAT.
Dude, I wanted to be a doctor. Almost all medical terms use Latin. Almost every bone in your body's named after a Latin word.
Yeah.
No, I just played doctor here at school with the med class,
Exactly.
Was taking Latin one of the worst choices you made in high school?
No, it was kind of cool. So the reason we offered Latin at our high school, this was the goofiest thing. The reason we offered Latin at my high school was
Easy language credit?
no, it was hard. But we were the only high school that offered it, and so then we found out there was other football players in the Tempe area so we could build a really good football program, so they could transfer our school to take Latin, even though they live in the feeder area, so we had a really good football program. And it actually backfired on us. We had like the worst football program. My first varsity game I played in as a sophomore We lost 77-7. And they didn't have a running clock back then. Yeah, oh, it was horrible. Brian Hooks was the only one who got a scoop 6. Guy fumbled it. Brian Hooks comes barreling through, picking it as a scoop, runs it for about a 30-yard touchdown. Oh, we were horrible.
How did it backfire?
Because all the other schools started offering Latin as well, so all the really good football players stayed at their school. They caught on to it real quick. So I was basically sitting in my Latin class with all the other football players, and then there was like a handful of freshmen like, oh, we want to take Latin. And it was like, what's this dude doing here? It's like, this is a class we're not supposed to do anything with.
I feel like
all right, find the conjugates. Here we go. Ready?
He would do that.
What did I do? 7 plus root A. You okay with that? 4 root 3 plus 5. Those are the conjugates, right?
Guys, it's just what makes them 0.
Yeah.
Okay.
1 minus root 6. 9 minus 2 root 3. That's how you find the conjugate. When you multiply them together, your middle terms drop out, which is kind of cool.
But how do you use it?
That's how you rationalize your denominators. You don't want a radical in your denominator. And I told you guys the other day that when we rationalize the denominator, we don't want our square root in the denominator because back in the old day it was hard to divide a square root into another square root. It's really the honest goodness reason. I know some people will say, nope, doesn't work that way.
I think you're just too rooted in your tradition.
Gotcha. So conjugate binomial expression that, didn't we just do that one?
Yeah, you went up.
Sorry. All right, ready? Put that in parentheses first thing. Still with me?
Yep.
3 minus root 2. Multiply that top and bottom. Some of you are talking too much. I know you're doing well in this class, but I want to make sure we all do well. All right, let's see. That's going to give me 9 minus 2. 9 minus 2 is 7. Check to see if that 7 reduces with any of the outside terms. It does not. Done. You feel comfortable with how I just found that answer?
Yep.
Sweet. All right. Next one. Put that in parentheses. Still with me? What's the conjugate of that?
2 plus.
2 plus 4 root 5. And do that both top and bottom. All right, so distribute on top, so I'm going to get 12 plus 24 root 5 on top. If I multiply the bottom, that's going to give me 4. And then, so I'm going to do this 4, and it's going to be minus 16 root 5, or 16 root 25. So 4 minus 16 times 5. What's 16 times 5?
16 times 5.
80. So I'm going to subtract, so that's giving me negative 76. 2, 24, and 76 are all even numbers. Does 4 go into all of them? 4 does? Does 4 go into 76? 4 goes in each of these? 5. And then negative 4 goes into 76 16 times? Did I do that right?
Yep.
I think
Is it 19?
yeah.
It's 19.
19? Okay. There we go. Cool. Any questions on that?
No, sir.
Still got time? Can I move on?
Yeah.
Okay.
Do you want more than skip to 17?
Ready? So conjugate 4 plus root 5, still with me? So on top I'm going to get 4 root 10 plus root 50. Root 50 is going to break down eventually. So I'm going to get 4 minus 1. 4 minus 1 is 3. So that's almost done. If you left it like that, this is a 3-point problem. You'd miss 1 point. 4 root 10 stays as is. That's going to become 5 root 2. Good. Did I do that wrong? It should be negative 3. 4 minus 1. Yeah, it's just 4 minus 1. Or wait. No. 4 minus 5. 4 minus 5 is negative 1.
16 minus.
I am. What did I do wrong? Oh my gosh. 16 minus 5. So that's 11. Jeez. Gosh, I knew I shouldn't have. sniffed that glue this morning. It's just kind of.
That's fun waking up.
Sorry about that. Got all excited going through these things, goofing up totally. Kids are looking at me, getting confused. Grades are dropping.
Yeah, come on.
I tell ya. It's like, what'd you learn in math today? We sniffed glue. What?
Wait, are the quiz grades from last week in?
Yeah, thanks for listening.
I'm sorry.
All right, 25 minus 3. 5 root 15 stays as that. Minus 3 root 5. Uh-oh, I ran out of space. 3 root 5 over 22. So that's going to give me, oh, this is just nasty. 2 root 15 over 22. Oh my gosh. I'm dumb. Root 15 over 11. Can you follow my work? That's the answer right there.
What the
Now you guys know what it's like to grade your test. I'll tell you, I had people squeezing answers in here. You're like, what is that?
On this one? That was it. That's what I said.
It's rough.
That was it?
I still have an A.
All right, ready?
4 minutes.
Ready? I can do it. Square, square, x equals 49. Yay? Anyone stuck?
What's it?
49.
X equals plus or minus 7.
So that gives me 7.
God, I'm so sorry.
Plus or minus root 7. Hey! Shh. So if I square both sides, I get one answer. But if I take the square root of both sides, I have the positive and negative component, because remember, square root deals with a distance. So number 19, square, square.
121.
Done. This one, let's see, I'm going to multiply both sides by 4/3.
I think so.
So that's 36. Root. X equals plus or minus 6. Did I do that right?
Yeah.
So some of you are looking at that going, wait a minute. So if I multiply both sides by 4/3, 27 times 4 divided by 3 becomes 9 times 4, which is 36. So you have positive and negative components. No more math. Math is done. So tomorrow we will be marking off worksheet I.
No.
J. J. Love it.